When finding the trig ratios, it can be very helpful to draw a right triangle. Be mindful of where theta is placed. Also, don't try and draw the triangle lengths accurately. The drawing is a guidepost, nothing more. So for a right triangle, and we put theta in this acute angle, and here is the 90-degree part of the right triangle. From theta, the opposite side is the opposite, the side immediately next to it is the adjacent, and the longest side is always the hypotenuse. So this is what we're going to be using to find the 6 trig ratios. So we're going to find the 6 trig ratios from this given triangle, and this is where theta is located. So first one I'm going to do is I'm going to find sine of theta. And sine is just opposite divided by hypotenuse. So this is going to be 3 over 5. And that's the end. Next is cosine theta. And cosine is adjacent over hypotenuse. So cosine is going to be 4 over 5. And that's all for that. Last, we have tangent theta. And tangent is opposite over adjacent. So it's going to be 3 over 4. And that's tangent. Now we got to find the reciprocal of each one. And once we have these 3, the reciprocals are fairly easy. Cosecant theta, that's terrible, theta, there we go, theta, is just the reciprocal of sine, so it's going to be 5/3. Next we have is secant, and secant is just the reciprocal of cosine, so it's going to be 5/4. And then last we have cotangent, which is just the reciprocal of tangent, so 4/3. And there are all 6 trig ratios from this triangle. Next, we're going to find the remaining trig ratios given the following ratio. I know that cosine alpha is equal to 3/4. So drawing my right triangle, again, it doesn't have to be accurate, it's just a right triangle. And here is my theta, or my alpha value. And I remember that cosine is just adjacent over hypotenuse. So adjacent 3, hypotenuse 4. Now I still have to find the opposite. And the way I do that from a right triangle given 2 sides is Pythagorean theorem. So I'm going to do 3 squared plus b squared equals 4 squared. Now, just going to expand this out, so 3 squared is 9, 4 squared is 16, and so I subtract that over, I'm going to get 7. And then I square root both sides, I'm going to get b equals the square root of 7. Now with typically you would have plus or minus with a square when you take a square root, but since we're dealing with lengths, we only want the positive length. So the opposite side is root 7. Now I can find the rest of my trig ratios. So I already know what cosine is. Sine of alpha is opposite over hypotenuse. So square root of 7 over 4. I'm done with that. Then we have tangent alpha. And tangent alpha is just going to be opposite over adjacent. So square root of 7 over 3. Now I need the reciprocal of each one, so reciprocal of cosine is secant, and that's just going to be 4/3. Now I need the reciprocal of sine, which is cosecant alpha, and that's just going to be 4 over root 7. But if you can't have a square root in the denominator, just rationalize it. And when you do that, you would end up with 4 root 7 over 7. And then last is cotangent of alpha, and that's just going to be the reciprocal of tangent, so 3 root 7. And if you cannot have a square root of the denominator, just rationalize it, and you're going to end up with 3 root 7 over 7. And that would be the 6 trig values, or at least in this case, the 5 remaining, for this question.